Hello and welcome, and thank you for joining me on this first episode of our series, Learning SQL with Trino from the Experts. My name is Manfred Moser, and over the course of these series of training classes, Martine, Dane, and David will join me. We'll do this every 2 weeks now until we reach Trino Summit in December. So what is this going to be about? Well, first of all, Martine, Dane, and David are the co-creators of Trino and CTOs at Starburst, so they definitely know about Trino. I know a little bit myself as well about it. I'm a Trino maintainer and advocate for Trino at Starburst, and I'm co-author of the book Trino, the Definitive Guide, which in fact you can get a free digital copy from Starburst, our sponsor for today's and the upcoming sessions. So thank you very much for everyone on that. Please make sure you get a copy. Today, we're going to get started with Trino and SQL. In the next sessions, we will go to the next level in taking SQL analytics to advanced features with Martine. Then we'll learn about getting data in and out even more so with David. And then last but not least, we'll learn about functions and more functions. In fact, even something called SQL routines, which are user-defined function, a brand new feature that's going to hit shortly, and hopefully will have hit by the time we teach this class in the end of November. So we already have documentation and everything ready for that. So super excited. I'm hoping you'll join us for all these upcoming sessions. For all of these sessions, including today, what we're going to do is I'm doing this introduction right now. Then we're going to dive into learning SQL with Trino. We have an open-ended Q&A afterwards, and we'll take roughly an hour. If it takes longer and you have lots and lots of good questions, bring them. I'm ready to try to answer them. And as I said, I'll try to answer them. And if not, I'll go off and find the answer for you and let you know later on Slack and other Trino channels. Today, we're going to go get started with Trino and SQL. So we'll start basic and create a common understanding on how Trino relates to SQL and how those two things work together. And we'll talk about differences to other systems as well. We'll basically create a foundation of understanding so that you know, even if you have SQL background, what's kind of different, what's new, what you have to keep in mind, and other aspects. There'll be a lot to learn, so it should be a good session. In terms of advice for you all attending me today, we have a chat, and I see some of you already frantically using it. That's awesome. Thank you so much for doing that. On this chat, answer any questions. Cole and Mandy and others are helping me in the background answer them, as well as aggregating them for the dedicated Q&A session after my presentations. Overall, this class is going to be pretty fast-paced. As you probably noticed, I'm also a fast talker, so I'll try to slow down so everyone can understand me. But don't try to follow along. I've done this demo a few times before, and I'm going to be pretty fast about it. I want you to pay attention and focus. It's no use you trying to follow along and just keeping tab on like cut and pasting text around. All the resources for this class, including the presentations, the SQL snippets, and everything will be available after class, including also a recording with timestamps and everything, so you can learn at your own pace and also apply those skills that you learn to your own data sets, and which will ultimately mean you'll learn a lot more from doing that. So just hang out with me today, grab a cup of coffee. You don't have to talk, you can just listen. So you should be good. In terms of the demo today, I'll be using Starburst Galaxy, which is a managed Trino platform, just because I'm lazy and it's the easiest thing to do. Starburst Galaxy is great because you can sign up for free, in fact, for a test account. And it provides you all the SQL features from Trino and more things like gravity. Trino, the analytics engine, is in the thing, but it also provides security and access to all sorts of data lakes and other data sources, which is what we're going to learn more about. All the demos also obviously work with Trino itself. So if you're not using Starburst Galaxy, that's too bad, but it's also good because you're still a Trino user and we love that. All the SQL will work, and you should be able to teach them all, check them all out. And we have documentation for running Trino if you really want to go down that route. But with that, let's learn some SQL with Trino. And by the way, there's a long debate if you should be saying SQL or SQL. I'm going to be flipping back and forth. I'm not very like religious about it. Whatever works in the context and whatever my mind tells me to roll with. So let's get started. I hope you're all ready. SQL and Trino concepts, what you need to know to get started. This is a continuation of a training / presentation called What is Trino that we did at the Trino Community broadcast in the past, and that is available as well. But in a nutshell, we'll talk about just a recap of what Trino is, and then we'll dive into what is SQL, and then we'll talk about some of the involved components so you understand how SQL and Trino relate to each other and what's involved, because some things are different. And the first thing of what's different is Trino itself. This is our massively long explanation of what Trino is. So let's go through this quickly. Trino is a ludicrously fast, open source, distributed, massively parallel processing SQL query engine designed to query large data sets from one or more disparate data sources. So let's unpack this a little bit, just to recap. Ludicrously fast, that's important. Trino was always designed to be very fast from the start, well over 10 years ago. The reason this is important is because no one wants to sit around, write a query, wait for 5 minutes or 10 minutes or an hour, see the result, only to realize that it didn't bring you the insight you wanted out of your data, and then you have to run the next query and wait again that long. So the faster processing your queries is, the better it is for using the experience. And that also means interactively, like just testing, running a query, running it again, refining it. And that's important. It's open source, has been open source for well over a decade. And that's part of why Trino is everywhere and lots of companies are using it. You can find out more who all these people are on the Trino website and beyond. It's distributed and massively parallel processing. That means you're not talking, when you're working with Trino, you're not working with one little server. You're working with a cluster of multiple machines that process your queries in parallel, many at the time, many data accesses at the same time, which means it's much faster. It also means it's much harder to operate. So like, it's not just like one little server. There might be 500 or like more involved. And that makes it a bit trickier. But Starburst Galaxy takes that pain away from you. And otherwise, if you really want to run it yourself, you can, because ultimately it's not that complicated with tools like Kubernetes and other aspects. SQL query engine. Well, SQL we'll talk a lot more about today, and query engine as well just means that it's a system that can process these queries from data sources, but the data sources are not part of the system. And that's the next part. That is very large data sources. So very large, I'm talking not just gigabytes, but petabytes and more, right? Like Trino can query massive data lakes, and we'll see what these disparate data sources are. And that's what brings Trino brings that to the table. So it can query these different data sources at high speed for your analytics. That's what Trino is. And now you see right in the center of this, there's SQL. So what is SQL? SQL stands for Structured Query Language, or SQL. It's a powerful declarative programming language that's been around for quite a long time. We'll talk about what declarative means as well. And it can do data management. So you can, create data, create tables, insert data, update it. So you can manipulate data. And importantly, and this is the first focus of Trino, although it can do data management and manipulation as well. But today we'll talk about mostly the analytics usage. Analytics means you look at the data, you get it out, you get certain subsets out, and hopefully understand better what's going on. So, all the way to like trending in like whatever your sales processes or like analytics of your website traffic and so on. It is a relational data model. We'll talk about that as well later in detail. It's very, very widespread. As I mentioned, it's been around for a long time. Might be lying now if I say this, but I'm kind of thinking it's nearly the 60s. So it's a long, long time that SQL has been around. But at the same time, it's been becoming more and more modern. It's not standing still. It has the long established history, but it's standardized at ISO ANSI SQL. And it's supported by lots of tools, and lots of people have been in this ecosystem a long time and know ANSI SQL. For example, I remember myself, I used to write SQL queries 20 years ago as a BI consultant that are like very, very long. And obviously they did not run on Trino. I wish I would have had Trino back then. But this experience helps everyone, because you can carry those skills forward, and it's never going to be something that you're not going to have as a helpful tool by your side. So that's what SQL is. So what does this look like in a very quick sort of high-level glance? Well, it looks something like that. Select name from tpch.tiny.nation, order by name. So you see, this kind of explains to the query engine, show me the name of all the nations sorted alphabetically. And where do you get that from? Well, from this nation table in the tiny schema of the tpch catalog. We'll talk about all these terms as well. But SQL sort of says, it looks like that in many cases. But where does the data come from, right? Like I'm having tpc.tiny.nation. The data comes from data sources. Data sources are in Trino, can be any system that can be manipulated in a way so that the data can be presented in a tabular format, and a Trino connector is available. And there's actually a lot of them. So if you look at a list on the Trino website, we have our data sources list here. There's all sorts of different systems, and you'll notice there's like things like MariaDB or MySQL or Postgres. So very traditional databases, but also other things like Hive. That was one of the first use cases, where this is literally just Hadoop system with a bunch of files on an object storage with some metadata, right? So very, very different, but most importantly, many, many different ones. So, and that's very much related to how companies use data, right? Like no company has only one database. They always have many, and Trino allows you to access them all. So there's different data source types, right? There's, like I mentioned, object storage systems, like, and then there's relational database management systems, so the typical databases that you know and hear of a lot. Document databases and other NoSQL databases, systems like Elasticsearch or MongoDB that have been very prominent for a while. And then obviously other things as well, key value stores or streaming systems like Kafka or Accumulate, older ones, and many, many others. Even like Google Sheets can be a data source. And it's kind of funny because Google Sheets is a little bit of like a spreadsheet kind of thing, but it shows the tabular format well, right? Like there's multiple sheets, there's tables, sort of those sheets basically with columns and rows, right? That's kind of what the tabular format is. So object storage types are the big four, so to speak: Hive, the Hadoop system with the Hive Metastore, the more modern ones, Iceberg, Delta Lake, and Hudi. All of those basically just mean that there's a bunch of files in special, like higher performance formats like org or Parquet on some cloud system or your own object storage system, Minio, or whatever it is. And then metadata about those files and the data structure within those files is available in some sort of system, and then you can query those. Advantages of these systems are that they're a bit cheaper to run than traditional databases, and they also scale very, very well. So they're very widely used all across now. Of course, the more traditional systems, relational database management systems, all the big names and more, are all supported by Trino. You see here Postgres, Oracle, SQL Server, and others. And then many others, right? You see ClickHouse, Druid, Elasticsearch, Apache Ignite, Kafka, Phoenix, SingleStore, Pinot. Lots of them all provide data and are very useful to store data in their own manner and have their own advantages and disadvantages. but these advantages mean that different teams will use those different data sources, but then that's good because it allows them to efficiently store them, but it's kind of bad because now you have no place to like easily query all of them unless you're using Trino and SQL, and that's what we're learning more today. So Trino has SQL support for all those data sources. So even if those data sources don't support SQL straight out of the box, right? Like even like Hive on its own, like if you like look at it at the raw thing, it's just a bunch of files and an object storage and some metadata, doesn't actually support SQL. Like if you look even further back to Hadoop, you would have to write your MapReduce things in Scala or something. You don't want to go down that route anymore these days, obviously. But even if you are like having multiple databases, like say you're using Oracle and Postgres, they are very, very similar, but not the same. And then you're writing different SQL and gets tricky, right? Like with Trino, using the same SQL for all your data sources, and the syntax is specific to Trino, but very close to ANSI SQL. So it will look very familiar to people that use like Oracle or PostgreSQL. And it's not, however, the syntax of the underlying database. So if you're like very knowledgeable about some specific SQL dialect, that's not necessarily going to translate completely. You'll have to adapt to the specific syntax from Trino, but most of the time it's going to be very close. And importantly, it supports SQL even if the data source does not. And that can be very helpful if you want to even do things like querying or manipulating a Google Sheets data sheet or querying data in Elasticsearch or some logging system on files. Trino allows you all of that with SQL and combine them all. What SQL specifically are we talking about? Well, Trino tries to follow the ANSI/ISO standard as close as possible. These standards come out with new versions every couple of years, and we try to A, anticipate what the standard will be, and B, especially when the standard has been sort of sanctioned, we will follow and update closely on them and add newer features that follow those versions. So just recently, we added some more JSON parsing and things like nested field support and so on. So, and more of these things are always coming, which is why it's useful to be on the latest version of Trino to get the latest features available. Things like the merge command has been added not so long ago. And that's useful to have power because it adds more power to your queries and ultimately means you have to write less complex stuff because these new features often make things easier to follow. We also go close to other standards that are widely used. So for example, there's some mapping functionality that's not part of the ISO ANSI standard, but it's still very much a thing that most systems support in the same syntax, so we follow along, right? So it doesn't get too crazy different from other users that come from a specific database background. Like say, for example, you used a lot of the PostgreSQL mapping extensions, the functions that we support for geospatial querying will look very familiar, right? And we'll stay close to other common features. If in doubt, you should check out the Trino documentation on in general, and then also on SQL. There's a lot of stuff here, which will help you to dive in deeper. So you see here, there's functions, all the functions that we have with different systems. And here I mentioned the geospatial ones, for example. Let's look like here. And then there is SQL language support overview, and then there's the statement syntax for all of these things. So, but we'll dive into all these aspects a little bit more soon. So make sure you take advantage of these resources going forward. But before we understand how to write these queries, we need to understand a few things. First of all, we need to understand what a catalog is. A catalog is basically a bunch of configuration pulled together and named, and that configuration allows you to access a specific data source. It uses a connector, but it also contains things like the credentials to access that data source and specific configuration on how you like to connect to it. Like maybe you only want read-only access to that data source and stuff like that. And you can create as many catalogs as you want. So you can create one catalog that accesses a database on Postgres, and then you can add another catalog that accesses another database on Postgres on the same Postgres server, for example, and then you can query those two at the same time. And then another one that connects to, say, an Iceberg data lake house system, and you add those in the query as well. They are always, each one of those data sources becomes available in Trino as a catalog. That's important to understand because that's what you query in Trino. You don't query the data source directly, you query a catalog, and a catalog can be a representation of some underlying data storage and data source system. The connector is that little plumbing sort of tool that knows how to talk to that data source. And that's used in the catalog. So it knows how to read and write data in the data source. It's configured in each catalog, and there's different ones. But it also translates and works with Trino to make the operations that you're requesting via your SQL queries to be suitable for the underlying system, right? Like a write operation on a org file in Iceberg is different than a write operation on a JSON file that's actually in an index in Elasticsearch. And that's different again from a write operation that's just an insert statement on a PostgreSQL database. Like it might be nearly the same statement, and then Postgres takes care of the headache underneath. So very different, and the connector for each one of those data sources takes care of how this works. And Trino then doesn't have to worry about it. The connector takes care of those details, basically. And those connectors are part of Trino. They established the tabular concept of the data, right? So if a system like Elasticsearch consists of documents and in indexes, well, they can be kind of translated to a bunch of nested tables and so on. And so that concept, that translation to this tabular concept is done by the connector. And it also includes type mapping, right? Like if an underlying system doesn't understand types and only has like, it stores text files, like some system that maybe like has a bunch of log files and they get exposed via a connector. Well, those log files are just ASCII text, but maybe the individual column in that ASCII text have a certain format and then can therefore be interpreted as different data types. So something like date versus a date time versus an integer number or a decimal number or just a string. Those kind of mappings and translations from the underlying system to the type maps that Trino uses, which are very rich, is done by the connector as well. So not all connectors are equal, I mentioned, right? Object storage connectors, they read and write the metadata, but they read and write the object storage files directly as well. So Trino is very close to the metal there, super high performant. On a relational database management system, that's typically not what the connector does. The connector just kind of translates the SQL and passes it over via a JDBC driver, and then the relational database management system just runs a translated SQL of its internal SQL, right? And then others, again, are very different, right? Like some systems like Elasticsearch, so they have an API available, maybe even a REST API. Like we have a connector that can like work with a random REST API, right? These then are translated differently. So connectors have to do very different work depending on what they need to do. I also noticed that Chris Lee is asking if there's a connector for AWS S3. Yes, there is, kind of, but not really. Well, yes, there is very much so. What you have to look at here is object storage systems. When you say S3, Amazon S3 is just a object storage system. So that's just a bunch of files, basically. And files on a cloud like S3 or Google Cloud Storage or Azure Storage or other systems, they have metadata with them. And with that metadata in a format like Iceberg, Delta Lake, Hudi, or the old legacy Hive, you can then query those things. So yes, there is very much a core use case of Trino. In fact, it started by querying files on the Hadoop file system via Hive and tremendously increased the performance. So definitely a very core use case. And the connectors, as I mentioned, are not all the same. In this case, S3 would be an object storage file. So it's an object storage connector where the files are written by Trino. And as I mentioned, Trino needs a tabular data format. So catalogs, we now know, are exposing that configuration that exposes a data source. Catalogs contain one or more schemas, and a schema is often equivalent to what's called a database or in the external system. Sometimes it's also the catalog. It depends on the external system. But it can be one or more schemas. That depends on the configuration. A schema then contains one or more tables. And then a table contains one or more columns. Each column has a specific data type. As I mentioned, it could be date or string or integer numbers. And then each row in a table presents a record set or data set. Kind of think of it like a spreadsheet, right? Like each individual cell in the different rows and so on has a different value, a different format, and that's what you get back from your queries. When you're talking or querying Trino, you're querying a Trino cluster. So there's one URL to connect to, but under the hood, there's many servers that process those queries. There can be many catalogs for many data sources. Typically, there's not just one user using the system, so there's many users, and they process, and the cluster processes many queries. And with all that set up and all these concepts understood, you can run a SQL statement like we just mentioned earlier, but now a bit more abstract. If I go here, select star, that says get me all the columns now from a catalog, a specific schema, a specific table, and then where, and here's a specific column follows some pattern. That SQL statement will work for any kind of syntax, will work for any connected data source. And note that by going catalog.schema, you are fully qualifying where that table is. And you can be in many of them, like many connected data sources. We'll look at that in more detail later. But first we have to go sort of the other side, right? Like there's the Trino cluster now, it runs the queries. But where do we run these queries? Well, you run it in a client. A client is connected to the Trino cluster, and that's where you write your SQL queries, you run the queries, and you receive the results. Clients can also be much more powerful and beautiful in terms of they can orchestrate multiple queries and run a data pipeline and like have them scheduled running. They can create reports, produce dashboards with, beautiful visualizations of maps and chart diagrams and bar charts, whatever you like, right? Like whatever the tool can then produce out of the data that Trino can provide from the data sources, the clients are doing that. In my case, I don't have to worry about all of that because I'm going to be using Starburst Galaxy. So the client is kind of like part of the web UI. So I can just use what's called the query editor, and we'll see that in action later. But there's different clients available. There's desktop applications, web applications, the Trino CLI, something that the Trino project itself ships. There's the JDBC driver and the Trino Python client that enables many clients, and there's others as well. So if you look at the list of the clients on the website, you see there is more. Like there's all these, and some of those names will look very familiar, all the way to Jupyter notebooks and like just anything Python you write, or even things like Visual Studio Code. You can literally in your IDE or data grip in your development environment just start typing away. And of course, Trino itself ships the Trino CLI, so you can literally type on the command line as well. So very many choices available. Oops, wrong slide deck. So that's the overview. So in conclusion, let's read this sentence together and see if we understand what's going on a bit better now. So you can write a SQL query in a client that is connected to a Trino cluster. We saw what a SQL query looks like. The tool we write this query in is called a client. It's connected to a Trino cluster. The Trino cluster, or Trino, basically retrieves data from the data sources, important sources. There's multiple, with the help of the catalog configuration. So the catalog is that system in which you query. And the connector understands how to access the data in the underlying data sources. So that's sort of how Trino hangs together. Importantly, right, there's a cluster of many machines helping you, and you're querying multiple catalogs. And now we're ready to go and learn more and put those concepts a bit more to the metal by looking at SQL basics. This is, again, a beginner's welcome kind of setup where we start and get going on the basics of SQL. So we have the cluster running, we have the data sources already connected, and you have our client tool of choice ready. Now we can run some SQL queries, but how do they look like? First of all, I want to talk about something that's very important to understand when you're writing and thinking about how you're phrasing your Trino queries. It's a bit of a different mindset from typical development life cycle, kind of like if you're like a Java developer or a Python script, then you have to think about this a bit differently. SQL is declarative, not procedural. So a typical SQL statement here, again, this little example here, select name. So from tpch.tiny.nation, where name like M% is declarative in the sense that you're basically telling the Trino engine here, get me all the nation names that start with the letter M. So you're just saying, hey, get me this, to like, you know, think of like some helper system that does it for you. You don't have to explain to the system how to do that. So you don't have to think procedurally. You don't have to go, well, I have to load all the nations and then have to loop through each one and then have to check them, get the name from them, check the name starts with M, and the ones that I don't start with M, I have to filter them out, and then I make a list and then I return a list. That's the procedural way of thinking in terms of programming. That's not what you have to do with SQL. With SQL, you just have to say what you want. And then the SQL query engine, our lovely Trino system, will have to worry about the how. You just specify the what. So give me that data, please. Pretty please, right? So let's look at what different statements we can write with Trino. There's lots of different ones. So there's globally available statements, read operations. So that's the typical analytics stuff. There's write operations. So that's where we create data, we manipulate data. And then there's also security operations. Globally available statements are things like use, catalog.schema, explain, analyze, set, reset, show session, show functions, and numerous others. And then also metadata operation, like show catalogs, show schemas, show tables. So let's explore some of those. If you go over here, I am in Starburst Galaxy here. Just think of it as a Trino system that's already up and running. I don't need to worry about any details. And I'm here connected in this sample cluster. The sample cluster here has 1, 2, 3 catalogs configured. And I see this in the UI, and it's very convenient, but I could also like just run the show catalogs query. And you see this takes a little bit longer now because the server will start, but then once it's up and running, we don't have to worry about it. This will basically produce this list for me as an output of a query. So this show catalogs is a first query that we hit, and it's going to produce this list for me. And then if I look here further down, it'll also allow me to see other queries and add the other information here. So you see here, there's the sample catalog. And we see it in the list here now. There's sample, there's system. The system catalog is always there. It sort of provides the data about the system itself. And then there's TPC-DS and TPCH. So this is the same thing we see here, but now we ran a command, a SQL command to run this. So similar, if I run this command, show schemas from sample, we get the samples. Then I can go all the way to like, you know, do something like show me the tables from tpch.tiny. That's a schema, and you see that's the tables. Show session is a bit different. Show session shows me all the defined variables that are configuration variables. And I can, for example, do something like show session dist. And it shows me just those. This pattern here, this like, is the SQL syntax for pattern matching. This percentage means any number of characters. If I go underscore, that would be just one character. And in this case, it would return nothing. So if I see this, right, there's no dist and then letter A or something. But I can do something like, for example, set session distributed sort false. If I run this again, and this is very much the internals of Trino. Typically, you don't have to worry about it, but it can be useful to just know what's going on if you dive very deep. Much more interesting is you can see, for example, Trino can show you all the supported functions. So here, for example, I'm going, show me all the functions that are called concat something. And it does that here. And you see that there's multiple concat functions which allow you to concatenate the given texts. But you see it can do it for varchar, for var binary, and even for arrays. And then there's also the var concat ws kind of functions. All these functions are different. Now, if I go here up, you also see my context is I'm working in the sample cluster in the TPCH catalog in the tiny schema. I can use the drop down here, but if you're any other client, you can also just type use TPC like ds.tiny, for example. Oops, sorry. Bit rusty this morning in my typing, and you see this was a typo, so run it again. What? And it says there's catalog doesn't exist, TP CDS. So you see the error messages are also useful. And this now finished. So now, and you see here, it's now TPCS. I can go back. And now if I go look at the tables here in tpcds.tiny, I can just use the tree or run a query to give me that data. And you see there's different data here. But let's run an actual query. Select name from tpctiny.nation. And you see here, it shows me the list of countries that is in this sample data set called TPCH. Explain is a system that allows you to sort of ask the system, so how are you kind of getting this data? This gets very technical quickly, but it's useful to know. You can also go explain, analyze. And you see the IDE here helps me by completing commands and gives me even more information. This goes very much into the depth of the system. So Trino has lots of these kind of commands available. So you see, including also things like show me the columns of a table or describe the table is the same thing. You can go show create. So show me how to create that table, like show me the grants and roles, show me the stats for available. So there's lots of these kind of show commands that allow you to explore the metadata of Trino more. But we want to dive over into the read operations. That's the power of any analytics query. We'll talk about this more, but it always has these select statements. Read operations are available with all connectors. It's kind of a minimum requirement. If you can't read data from that data source, it's kind of pointless. So they are always available for any of the data sources we talked about. Write operations support will vary, but it can be broken up into just data management, so inserting, deleting, but also more established stuff like can you create tables and schemas? Can you create what's called a materialized view or a view? We'll talk about this more advanced concepts in one of the next classes. But basically, write operations are about changing the data or changing the structure of the data. The coverage, as I mentioned, is very different for different connectors. All the more mature ones have pretty deep write operation coverers. And there's lots more power available with SQL and Trino. The price statements are very powerful. There's a lot more, right? Like there's scalar, aggregate, and table functions. There's operators. I mentioned SQL routines and user-defined functions, lots more power. And we want to dive into some of those now and then in the upcoming classes even more. As a side note, I want to quickly explain another classification that you'll come across in this ecosystem of data manipulation and data and analytics. You'll mention and find often there's typically you see DDL and DML coming up. So there's basically actually all 4 of them. There's DQL, which stands for data query language. So that's kind of like the analytics side. So often the select statement and any data you get out. Data definition language. And I just noticed that I messed these 2 up. Data definition language here is things like create, alter, drop tables. So where you define the data, and then data manipulation. So I will fix this slide deck. Data manipulation language is where you change the data. So you add new one with insert, or you, what happened here? How do I get out of this? Okay. You update data, merge data, and so on. And then last, the data control language is about granting and revoking security privileges to work with the data. Just as a FYI, this sometimes comes up and then you wondering what people mean. It's another classification, but we typically talk about read and write operations. And now we're going to dive more into the analytics. So that's the read operation mostly. So we look at the data, understand it more to see what's going on. Here, the main power is the select statement, and this is the sort of syntax reference for the select statement. And we're gonna sort of like give a bit of an overview of what this means. As you can see, this is a very, very deep topic. There is a lot to it. We're gonna scratch the surface today, and then next time with Martin, we'll dive into some of the more powerful things. So on a high level, this one says, get me the columns from a table in a schema in a catalog and consider conditions to filter data. And as a result, you get the data in tabular format. So you can see here, if I run this statement, I'll just throw it here. You see, I get Morocco and Mozambique out of this data source, right? Like pretty nice and easy. I can go and change this over to like say you get United Kingdom and United States. So very simple. You get the data in tabular format. So if I, for example, go over here and go, and I can see here in dpch.tiny.nation, this is tpcds. So I can query, or I can just like cheat and look around here. And there's, I think, a field called description. Oh no, it's like notes or so. No, don't remember now. But we can just run it and see if it fails. Or what you can also do is we can show me all columns, which is star, and you see there is a nation key, a region key, and some. It's a comment. Okay, so I can go name, comma, comment. So I can decide which data gets back to me, right? That data comes back in different data types, right? So different things come back differently. So each column has a data type. In our example here, these name and comment are both text strings, right? Like they're varchar. But like the region key, for example, is a number. So different columns each have a different data type, and the connector is the thing that translates this. But it's important to understand what the data type is, because it will allow you to manipulate it differently, right? Like if something is text, then you can cut it shorter, longer. If something is a number, you can't just cut off some digits and think it is going to be the same. Or if something is a date, then you have lots of options on how to render this date out to make it useful for the consumer, versus like someone in Europe might want the ISO date format, someone in the US might want like different order of date and different like dashes versus slashes or whatever, or maybe you want the name of the month spelled out, right? Like all these things are different, and there's different things you can do how to find that out. So if you look at this here. How do you find out the data type of results? Well, you can do a prepared statement and then describe the output. So if I go over here, no, I think I have this here. So if I can go prepare, so I'm preparing a query. I call it test, and then I describe the output. Oh, why is this not happening? Oh, I have to go use tpch.tiny. So I just did that. Use tpch.tiny. I have to use that because you see here, this nation is not qualified, right? So why is this not happening now? tpch.tiny.nation. Yeah, there you go. Fully qualified now. And you see now it shows me the output, describe output. I see that name and comment are both the data type varchar, but name is only 25 characters long. Comment can be up to 152 characters, right? So different data types. If I go and, for example, also go nation key, here is another column, and then describe the output, you see that nation key is actually a big integer value, right? So very different, will render differently in a query. So that's describing the output. Of course, what you can also do is you can just find out the data type of the results by running the query. That's sometimes an option, but sometimes not really an option because maybe the query, running the query takes a long time. But what you can do is you can do something like limit, which reduces the number of records returned, and then you can see it with the actual rendering. So if I run this query over here with limit 1, for example, I only get 1 record back. I know what it's rendered like. It shows me the name, right? It's not showing me the flag of the country as an image or something. It shows me the name. And it's in all uppercase, for example. So I know by running that as a test query. So it's useful for testing to do that kind of thing. Now, what's also useful for testing is not even needing a catalog. If you want to just test some queries or so, you can do something like this, right? Like this doesn't use any kind of catalog, right? Like you look at here, I'm going select. So give me the string today's date and concatenate it with the current date that is being cast to a character, varchar. So if I run this, if I have it here somewhere, and if not, I'm just going to cut and paste it. Here it is. You see, I get today. I can also do values, which is a bit more powerful because it can do multiple. So I can go like this, for example, and now I have 2 rows. And you see, these are still 2 rows, 1 value each, because I'm here concatenating them together. This is a bit more complex though. You see, I'm using current timestamp. I'm adding 1 day with the date add function to the current timestamp. And then I'm using the date format function and formatting into the isodate format, right? So that's how I get this kind of look and feel. With values, I can also go even further and basically create a sort of like table on the fly with random values. So if I go like this and run this query, you see now I actually get a description column and a date column with a string, and in this case still a string, but I could also leave that as a date and then do some further manipulation or whatever. So this is values, very useful for testing like your formatting. Here is some more complex values formatting that we'll look in a second. So very easy for testing. Also, as I mentioned here, you can return 1 or more rows with this, and we looked at this already. Now, how can you format data types? Well, you can use cast, which basically says try to take this data type date and show it as a varchar. And you see this worked in this case. You can be more explicit about it. You can use the format function, and there's many other data type specific functions to manipulate the data to look like you want. Obviously, it only goes to so far, right? Like it can render it as a text. If you want to go even further, then you need a client tool that understands even more, right? Like client tools do things like, well, they can translate geospatial coordinates into actual rendering it on a map, for example, or they can translate output data into like, colorful bar charts and get that kind of stuff. SQL on itself always only produces text output in a tabular format. And then beyond that, it's visualization tools that help you. Casting is the first thing that we just saw before. It actually affects the data type. So it changes the data type. In our case, before we looked at, it changed the data type from text to, it changed the data type from date to text. That can lose information, can also fail. But then the results can be processed with other functions for those other data types, which can be very useful. Like the format function, for example, here, it produces here the pi number, and then it formats it differently and makes a string out of it. All those kind of functionality is really useful, right? So here, format, changing this date to be formatted differently. If I run all this, you can see I'm getting Tuesday, July the 4th, 2006 out of this ISO date, for example. Oops. Data type specific functions, there's so many, and we'll have a special class about functions later in November. You can also manipulate what fields are returned with a case function here. So there's a little bit of like procedural programming in here in this statement where you go case, when, then in this little subsection. And you see here, this is a useful little hack. Values is being returned, and then it changes the output to these texts in here. You can also use a search text, a searched case statement. So this is right, someone get rid of this Mac stuff for me. All right. So this is searched with an in statement. An if expression is even more powerful, right? Like, so if you run this statement, for example, you can see that it's smart enough to go and let's just throw this at the bottom here. You see it guys, I have 0 cats, I have 1 cat, and that 1 cat here, this if statement here goes, if n is 1, n is basically the value out of this table, it adds the s or not, right? So if statements are even supported in this little manipulation of the returned values here. Try expression is also similar. Is useful because sometimes casting can fail. This allows you to not fail. So if you have lots of records, at least you get some sort of nulls returned rather than queries failing. So it can be very useful when you do operations where you don't necessarily know what all the values are. These are examples right here. More importantly, for our queries, so we have all this data returned. Conditions in the where clause allow us to narrow down what data is returned. So we have multiple conditions and or not, and then all these operators we can match with patterns and so on. In those conditions, that's a very large topic. We'll have a simple example here where name like you and region key is not equal 1. So for example, here we have 2 conditions. If I run this query, you can see that it just returns United Kingdom. If I leave this condition out, it also returns the United States, right? Like, and you see the region key is 3 and 1. This condition allows me to create multiple filters on what data to return. You can also sort the data by 1 or more columns. So for example, here we would return all the nations, but only the top 3, and in reverse order, right? So in this list, Vietnam happens to be the last country in the alphabet, and in descending order, we get it as the first one. So that sorting results is possible. You can also, and this gets very much to the core of Trino, you can also create where condition, access multiple tables. So in this case, for example, very simple example, we are not just displaying the region, like the countries, we are displaying also the regions those countries are in, right? So Algeria, Ethiopia, Kenya are in Africa versus like, Canada or whatever is in America. So we explain these different regions, and you can combine them because these tables both have this relationship established in their data. So you can go where region key in the other in each table. And you see here I'm doing things like I'm naming the tables, like I'm naming the tables N and R, and then I'm using that distinction here, and then I'm giving it here a nice title. So this is how I can access multiple tables. I'm just doing 2 here. Lots of the time you can do many, many more tables, and it gets very complicated, but also very powerful. When you do that, you probably want to use the join statement. This is equivalent now. You see, I'm joining the nation table with the region table on the same relationship. But the difference is that join is much more powerful for advanced usage, and it can do returning all results of both tables, and treatments of like null can be different, and so on. Very complex topic that I'll leave you to explore more on your own. On a nutshell, this simple statement is equivalent though. With these multiple tables, they can also be in different schemas, which is quite cool because different schemas with different catalogs can potentially be different databases. So you could have a PostgreSQL like a catalog that accesses a PostgreSQL database with 2 schemas, and now you can query them at the same time in Trino. That's not something you can do in other systems. You can even go across catalogs. So you can have a catalog that has some data in Postgres and another in an Iceberg data lake, or in an old legacy Hive system, or Elasticsearch, or some log files, whatever. You can query them together and therefore get much better understanding of your data than if you look at them in isolation or try to have some process to pull them together in another database again. These queries are often called federated queries. Very, very powerful core feature of Trino that you'll never want to miss again once you've used it. The select statement has many more complex features, and with things like group by, window functions, make, recognize, which we'll deal with a lot more next time with Martin. This was a whirlwind tour, and even in my whirlwind tour, I already went nearly over time. We'll still have time, don't worry, for questions and so on, if you just hang out with me or watch the recording later on. With this whirlwind tour, I kind of gave you an overview on how to get started with SQL, what it looks like, also how it works with Trino. How do you learn more? Well, there's lots and lots of generic SQL training material available. So take advantage of this. Starburst has the training material in the Starburst Academy, but there's also many, many classes from many years of people using SQL around there on places like, I don't know, Khan Academy or whatever you can think of. Lots of them available, books in your library everywhere. These are all suitable to learn the SQL concepts. Trino, following the ISO ANSI SQL standards, will most likely, like with a lot of them stuff, will work with a lot of them. And then you can practice with Trino. Some things are a little bit different here and there, but you can consult the documentation of Trino to figure out those. And of course, you can also find us on Slack and other places for help. And we'll do more training classes as well. But the most important thing about learning SQL and Trino is practicing. Practice. The more you write these things, the more you fall into traps. You can also help other people, like on the QA channel here. People have questions, but on Slack and other places, there are questions. Try to answer them yourself. Figure out, join on Slack, help people out, or try answering questions on Stack Overflow or the Starburst forum, and practice. It'll make you more perfect, so to speak. So that was our training today. And as you saw, I used Starburst Galaxy, which has been very nice here, fast, and get all the results back, and I can easily browse things. In terms of resources, we do have more training classes coming up. These slides will also be available. I'll write a blog post with timestamps and that kind of stuff. The Trino documentation and website at trino.io, we saw it a little bit earlier already, is available. The Trino Slack community at trinodb.slack.com is available. As I mentioned, the presentation, there's the TrinoDB presentations repository where you can see those slides. I'm running them locally, but you can also see them right for it there. The Starburst forum is available for you to ask any questions about Starburst products as well as Trino and SQL. And then there's a bunch of free, really cool training courses also available that are pre-recorded that you can watch on Starburst Academy. All of those are helpful and useful for you to dive into more. And as I mentioned, we'll have more sessions coming up with Martine, Dane, and David in the next weeks. Now, we still have time, well, kind of overtime, but still have time. I'm going to take the time and I'm going to look through a little bit on what questions are being shown up. Cole has been so graceful as to assemble some of those things for me. So let's see. So there's one question. Doesn't MPP imply distributed, or are they referring to it a different feature? No, like when we say the Trino definition, massively parallel processing, that kind of implies distributed, but you can have a distributed system where it's not parallel processing, where each individual task goes into the distributed system and is just executed in one part. But Trino literally can have a query where, say, a query accesses a data system like Iceberg, and there's lots of different files in different directories that are exposed. While different parts of the Trino cluster called workers can read the files separately in parallel and process them at the same time. So that's the massively parallel processing aspect. So a query can potentially, like one query can potentially use 10 servers at the same time. So it's massively parallel processing. It's also parallel processing in each worker. So there's, if me and Cole and 5 other people all fire queries at it, they will all run at the same time to some degree as well. So it's distributed because it's multiple system, but it's more than just a distributed system that can do things in isolation separately in that distributed setup. I know Spark and Trino are very different technology. Is it correct to say people reach out to these in general, speed up their data pipeline? Why would someone choose one technology over the other? Why would you choose Spark over Trino? Well, I'm very partial about that. So I'm going to just answer it because Trino is faster and better. Obviously, opinions will vary there. Spark is a great system, has been around a long time. And lots of people also use it successfully. But if I were to choose, I would choose Trino. Next question. Oh, yeah, I did do that already. But again, just a quick reminder, please do make sure that you register for the next classes, but also register for Trino Summit. Our yearly conference will have our yearly fall conference. We had Trino Fest earlier this year, and now we're having Trino Summit in December. It's a virtual free event, and people that use Trino all across the world will present about their success stories with Trino and their usage with Trino. It's always super exciting and interesting to see how very large companies and very small companies all use Trino successfully. Just as a reference also, if you look at the Trino website here, these are all names that you might know or not know of that are using Trino. And that's only a very small subset of the companies that use Trino. And maybe you should be in this list too. Now jumping back here. So yeah, register for Trino Summit on this URL, or if you don't know, just go to the Trino website, go to the blog, and you see there is the Join Us for Trino Summit blog post where you can find the link to register to attend. Or also, if you have a story and you're already using Trino, please do submit a talk. We would always love to hear how you using Trino successfully. Now, I'm going to look at some more questions. What are typical monitoring metrics we will have to look for in a Trino cluster for ops? That's a very, very deep topic, but obviously you want to look at things like memory utilization, processing. There's lots of metrics available via a system called JMX. There's another system available called OpenTelemetry. Both of those allow you to understand and show what's available and used on resources. There's also the system catalog on Trino that exposes a lot of information. And then typically systems like Starburst Galaxy have a lot of stuff in terms of visualizing all that and helping you manage that, right? Like the more you get deep into the weeds on this, the more complicated it gets. It's very, very powerful, but it's also a lot of work to manage it all yourself. To get started, I would recommend just get a Starburst Galaxy cluster up and running and get used to it, see what it does for you. And then you can always decide to stick with the power and convenience of it, or maybe move to Trino if you really think so. But that then you can decide that later. Cole, there's another question. Can we create views in Trino just like in any RDBMS, including tables from different catalogs? Yes, you can. The answer is a bit more complicated, but essentially yes. Views and materialized views are supported in Trino. We will talk about this more in my class that I'm joined by with David coming up about data in and out. So make sure you join me for that class to learn all the details about views. In cases where you're using only one non-distributed data source, is each worker connecting to the data source and pulling its own chunk, or are there splits done by the coordinator? That depends. There is connectors that can do that, reading in chunks, and some do and some don't. But, you know, like a typical query that's like more than just like reading from one table will access multiple tables, and then at least the access from the different tables is done by separate workers. So it's always parallel in one way or another. How parallel will depend a lot on the connector. The most parallel usage you get out of the object storage connectors, and that's obviously one of the core usages of Trino as well. Right, so that's the questions I see here. Now jumping over here in public. Okay, a little question. What's the difference between SQL Server and Trino? That's are they complements? In my opinion, yes, they are. SQL Server or Oracle or PostgreSQL and stuff like that, those are full databases. So they combine the storage aspect of like how these are stored and the query aspect into one system. Very convenient, very powerful, but also very expensive sometimes, and very narrow in the sense that it only can do that one thing well, right? Typically, companies have more than one of those. And that's where it becomes convenient to have something like Trino, because you can still query multiple of these databases and systems together, right? Like you have a company, even if you have a very small company, you probably have things like a website running that has logs and maybe some shopping system or whatever, and then a HR system and whatever. Like as soon as you want to combine these data systems, you either have to build up something very complicated to combine the data. It's called an ETL process and a data pipeline, and there's a lot of stuff to it. Or you just create a Trino cluster connector to data sources and query it all at once, right? So those systems are complementary. Trino can also be used to even shuffle data around these systems, right? Like say, for example, you have a very expensive, big relational database system, and the old data from many, many years ago is not really necessary in the database anymore. Well, you could run a query that shuffles that data out of the data system into a object storage system, and you can run that via Trino as one query. And then you can delete it in the big legacy server. You still have it in the other system. In the new system, Trino can still access both data at the same time, but you don't have to like pay for the massively big upgrade necessary for that legacy server, for example, because the data can now sit in the object storage for cheap somewhere on the cloud. Those kind of use cases are very useful with Trino, and me and David will talk about this more in the data in and out session. Is there a table that contains different catalogs? Yes, so like similar to SQL's information schema. So yes, the system schema and like the system catalog contains a lot of metadata information, and each catalog also has an information schema in which you can look at all that information. Show catalogs and that kind of stuff basically are convenience methods to access these queries, but you can also dive right into it if you want to sort of like mess around in the guts of the system. That's totally feasible and possible. All right. Now can you wait for... Sorry, by the way, for looking to the side here, because my secondary screen is where the comments are. All right, I think that is all the questions I see. Oh, no, there's more here in the Q&A tab. Okay. Can we use Trino as a query engine to power reporting analytics with high concurrency? Yes, you can, very much so. It's a core use case of Trino and very often used. And as I showed you earlier, these are all the supported clients, right? So like very powerful systems like Apache Superset can do amazing things to make things look very, very pretty. Things like Apache Airflow or Dolphin Scheduler or dbt can build very complex flows of the data with Trino. And at the same time, you can hack around it on the Trino CLI, right? So definitely a core use case, very high concurrency, many users, very common. Is there a table that contains the different catalog schemas? Yes, that's the metadata. There's multiple tables like that, as I mentioned. What's the difference between SQL Server and Trino? I mentioned one is a full database, but only for its one purpose of relational databases. Trino is a query engine that can connect to all these different data sources, right? Like, so again, here on this page here, all these different data sources are supported by Trino at the same time, which is very different from just like querying one of those systems. There's a question about the Unity catalog with the Delta Lake. Yeah, that support is coming / like there. Spark and Trino. Where can you find more information about explain and explain analyze? Very much two resources I recommend here. A, look at the documentation. The Trino documentation is very rich and has things like here, analyze, and then explain, analyze as well. Where are we? Explain, analyze, and explain. So there's information here. But then also the Trino book that I mentioned that you can download for free from Starburst is available. And it also is available, by the way, in Polish and Chinese now. in case that is more suitable for you. So you look at those books available online, again, on the Trino website in Get Started, books. Here's the book and links to where to get the book editions. And there's also example code repository with the book where you can follow those example queries as well. So there's lots more there to learn. I'm not able to query table with partition. That's just a setup question. It is possible to do that, obviously. Good answer, by the way. Yeah, join us on Trino Slack, again, on the Trino website here, Community Slack. Jump in and we can help you there. There's a question about writing CSV in AWS with Trino and some problem. Again, troubleshooting like that, please join us on Slack. General note, don't use CSV as a file format. It's very slow. So you want to use something better than that, ideally. Can we read a schema of a file in CSV or Parquet format on an object storage using... Yes, essentially, the rest of the question disappeared, but yes, you basically can. Will Starburst ever support data sources inside Oracle Cloud? Well, probably coming up. I encourage you to follow the announcements from Starburst on the Starburst website and just connect to the Starburst team. They can tell you more details on what's coming where and when. Lots is coming all the time, basically. And I think that's all the questions. So again, thank you so much for joining me today. I hope you got a bit of an understanding of how Trino is different from a normal database, but how it's also very similar in the sense that you can continue to use and expand your SQL usage for all the different connected data sources, query those catalogs, and access those tables in the schemas successfully. And make sure you take advantage of joining us on Slack and get your questions answered there or the Starburst forum. And I will see you next time and at Trino Summit in December. And with that, I think we're done for today. Thank you so much.